Welcome to this short recorded video that will go over the 4 activities that are not the summary activity for the Part A lecture notebook in Module 3. You will need to have NumPy imported as NumP for completing some of these activities. So I am going to go ahead and go to the first activity, that is exploring and manipulating a logical workflow. This is very similar to having to deal with some of the stuff that was shown above in terms of examples of if and else if commands. So in this exploring and manipulating a logical workflow, we're saying that the code below, which is shown here, attempts to evaluate this function. F of x equals the square root of x divided by x minus 2 times x minus 3. Those are both in the denominator. Of course, this is only valid for values of x greater than or equal to 0 because of the square root, and values that are not equal to 2 or 3 because of the denominator, which would result in a division by 0 if you gave x any of those values. So the first thing I ask you to do is try changing different values of x in the code snippets below and see what happens. So here we're saying, well, if x is equal to -1, we can run this initially. We see that we get the square root of a negative number. We're printing a useful output. This happens because x, in this first line, if x is greater than or equal to 0 and it's not 2 or 3, we will evaluate the function. Else if x is less than 0, we say, well, you're trying to take the square root of a negative number. That's not possible, and it assigns not a number from the NumPy constants, not a number, to the value of f. And so it's always assigning something to f in this, it's not always. In what we've done, we've assigned a value to f as not a number, and we've printed something useful to the screen for the user. Of course, if we try, let's say 2, we notice nothing happens. F is not assigned any value in this case, because here x is 2, so this part is false, right? Not x or 2. Well, x is 2, so this is definitely right. X is equal to 2 is now true, so that would make this false. This is supposed to be an and, even though this is true. True and false is false, and so it goes down here and says, well, x isn't less than 0, so it prints nothing to the screen. Just kind of nothing happens. So this is the point of the second instruction. The code is missing a control for the case where x is a value of 2 or 3. Add this case to the code so that f is always assigned some value, even if the value is not a number, in which case you should assign not a number. And some useful feedback is printed to the screen whenever a, let's say, bad value of x, one that's not in the domain of the function, is given. So what you could do here is quite simply, is you could say else, because the only other thing that could happen, right, if this was not true, it's either because x was less than 0 or one of these two values was true, meaning x was 2 or x equals 3. So in this case, I think really the simplest way to tackle this is to say else and then print and say, what's going on here? You want to print something useful to the screen. Some useful feedback is printed to the screen. That's part of the instructions here, is attempting to divide by 0. And then f equals np dot, not a number. So now, notice that is printed out, and f is always assigned an appropriate value, whether it's not a number or the actual value of the function, no matter what happens with x. If we try giving x 3, same thing. If we do with 3.0, we could see what happens. It will also check, because this equality check it's fine if that's an integer and that's a float. So that's checking this, and we're still getting the attempt to divide by 0, so f's always there. That's it. That's all you need to do for this activity. The second activity is to code a tent function. You're supposed to complete the code below to evaluate the function f of x equals 1 plus x when x is between -1 and 0. Excuse me, I just had to drink some water. So if x is between -1 and 0, including -1 or 0, then f of x is equal to 1 plus x. If x is greater than 0 but less than 1, then f should be equal to 1 minus x. And then otherwise, else x is equal to 0. So you're supposed to just complete this code and then test with some different values of x as well to check that all cases work. So in this case, here's if x is between -1 and 0, and it's including, right, that's greater than or equal to, less than or equal to 0, f is equal to 1 plus x. Else if what exactly? What are we trying to do here? Let me fix these code comments. You need to figure this part out. Well, it's not too bad. What we need is x to be greater than 0. 0 has to be less than x, and we need x to be less than 1. or equal to 1. That's it. Then f is equal to 1 minus x. Otherwise, else f is equal to 0. So if you run that, you get 0.5 when x is negative 0.5. And now, when we do 0.5, which is in this case, we get 0.5 again. This is this tent function. You can plot it by hand to see exactly why I would call it a tent function. So everything works, and then you can try giving a value like 10 and print f. F is assigned to 0. So that's it. That's all you really have to do for that activity. So let's go down to the next activity. It starts getting a little bit more complicated. So here you are doing a temperature converter function. So now we're actually defining a user-defined function. You are to complete the codes below that either converts a temperature given in Celsius to Fahrenheit, a temperature given in Fahrenheit to Celsius, or if two temperatures are given, meaning one in Celsius and one in Fahrenheit, they will check if they are the same. You are also to add a useful docstring to the function, and then you execute the code cells that follow. So your docstring has to go here. You should explain, how this function works. I'll get to that in a second. We'll first complete the code involving the logic and doing the execution, and then we'll come back and talk about the docstring. So if you look at this initially, and I'll just kind of fix up these code comments again, make them kind of conforming to the right standard of 2 spaces when they're in line with some code. So what's going on is if we default the f and the c values to none types. So if you just run this function without any inputs, the defaults are used, and the defaults are none. And so then it says, well, why are you bothering me? Like you didn't want to do anything. Else if f is none, right? So if this was false, that means at least one of these is not none. So was it the c value is not none? In that case, we check to see, well, is f none? Because that would mean c is not a none type. C was a value. So that means that the point of the function is to convert that Celsius to Fahrenheit. And that's exactly what would be done. It will print that Celsius, the degrees in Celsius, through the conversion of multiplying by 9/5 and adding 32, will say this is what the degrees are in Fahrenheit. Else if you gave a Fahrenheit, so Fahrenheit was not none, you actually gave it a value, and the Celsius is none, then that means you want to convert Fahrenheit to Celsius. So what you need to do is figure out what to put here. This is completing this part so that f is converted to c. I had to say it right here in the code comment. So we'll figure that out in a second, but let's just point out that the else command means that Fahrenheit and Celsius are both given. And so the point of the function is to determine if they're really the same temperature, just given in different units. So what it does is it checks the difference between the Fahrenheit and the conversion of the Celsius to Fahrenheit. And it's taking the absolute value of the difference between these two, and it's seeing if that's smaller than some number that accounts for basically round off error and finite precision arithmetic. So that's all that's going on here, is we're just checking some small value. You can check what this value is here. It's about 1.192 times 10 to the negative 7th. So we're just allowing for a little bit of error and saying that these are really the same temperatures if the two are within, 7 digits of accuracy of each other. So the only thing we need to figure out to complete this code to make it work is the conversion of Fahrenheit to Celsius. So we would say, just mimicking this part of the code here, we're just reversing the order. So let's say Fahrenheit. We would say this, casting that Fahrenheit value as a string, concatenate it with, equals, and then you can notice we can break long commands up within parentheses, the arithmetic, in this case, the string arithmetic of concatenation. It can be broken up across multiple lines for easier to read code. We now need to cast a string. I'll put that just for a second, what the conversion of Fahrenheit to Celsius is, and then say, this is what this is in Celsius. Okay, so what is the actual formula? If this is equal to Fahrenheit, solve for c as a function of f. You would subtract 32 and you would then multiply by 5/9. So you would take 5 divided by 9 times, and then you would have the Fahrenheit minus 32, right? That's it. Little algebra to solve for c as a function of f. So with this, everything should now work. And if you run this, these two temperatures should be really the same, just at different units. Hey, they're the same. So this part of the code ran. If I give 212 in Fahrenheit, it should give 100 in Celsius. Yes, it does. If I give 100 in Celsius, I should give 212 in Fahrenheit based on our conversion. It certainly did. If we just try to run this with no arguments, that of course works. And these two are what should print the stuff with the docstring. But notice your docstring is just your docstring. Should go here. We haven't written anything yet. What is a useful docstring? I want you to think about that. What is the type of information that you should put here? You can break this up across multiple lines. I would suggest structuring something like, saying something broadly like this function converts, Fahrenheit to Celsius or Celsius to Fahrenheit, or checks if a Fahrenheit and Celsius are the same if both are given. That's a very useful docstring. It says exactly what's going on with this function. And then you might say more about what the formulas are. You can make, like, what do you think is useful? I think, some things are like, inputs. You might say something about like F, the Fahrenheit, degrees in Fahrenheit. And, with default none. And then maybe C, degrees and degrees in Celsius. And again, with default none. Like, you could write more. It's just, think about what a useful doctrine would be. If somebody else was reading your code or you were looking at it later, that would just be useful for you to know. So I'm not going to continue to do it. I think that's something for you to think about. What would be a useful doctrine? Eventually what we get to, I'm just going to kind of undo all of the stuff here, is that, I want to redo the code comment parts so that they look good. There we go. We'll eventually talk about doc test, where you would put in sample runs of the code for usual operation that are useful to check if the code is still working, if changes have been made to it. But that's something that's covered in the homework. All right, but now with those things run, I think I know I've removed things, but I didn't run that code. I guess I did. I ran it again. So yeah, I didn't run the thing, but when you run these with your useful docstring, it should show up here. All right, let's go to that. Now we've done 3 of these activities. Let's look at the 4th one. So this is involving investment functions. It's very similar to what I had to do in this instructor-led activity that was in the lecture video. So in this one, I'm talking about something you've probably heard about, which is the power of compound interest. The basic formula boils down to this. A, which is the final amount, is equal to P, which is the initial principal balance, times 1 plus R over N, where R is the interest rate. And in this case, you would use a number of like 0.072 to represent a rate of 7.2%. N is the number of times the interest rate is applied per time period, meaning if it was compounded quarterly, you might have N equal 4. And T is the number of time periods that have elapsed. So if you were thinking in years and you had compounded quarterly, you'd have N equals 4. And if you invested for 5 years, then maybe you put T equals 5. So I ask you to make 2 functions, projected underscore balance and update underscore balance, in individual code cells below that have the following properties. Each function should use the formula above to perform element-wise operations on a NumPy array of P, R, N, and T values. For update balance, you should use an in-place operator to update the array of P values directly instead of creating a new A array. Comment your code with some explanation as to why this is okay in update balance, but not in projected balance, where a new array of A values should be returned. So let's think about what the point of this is. Projected balance is just a projection. It's a prediction. If you gave different types of principal initial investments at different interest rates with different compounding structures, and for different time values, what would the potential payout be at the end of the time values for all of these different types of investment strategies? And then as far as update balance goes, what you're really saying is you did update these values and you're trying to, let's say, update the spreadsheet, or the accounts. You want to change the values that are held, let's say, at the financial institution that's investing the money on behalf of others. So that's why update balance would perhaps use an in-place operator, whereas projected balance would not. And then, of course, I ask you to execute your functions with some different choices of arrays. Now, and we'll come back to this because we're going to focus on creating these functions first. There is a note here. You should encounter an error in the update balance function if you start with an array of principal values that are all of type int. I suggest you try this and see if you get an error like this. So ufunc means universal function in NumPy. when you apply a function to an array that's meant to be efficient. It's called a universal function. And you'll see that it will give a type error saying that what's happening when you do this formula is the output of it's going to be a float of type float, an array of type float. But if this is an integer array and you're trying to overwrite it by doing an in-place operation so that it creates a float array, there's a problem there because that array exists already as a data type of int, and so it can't be made into type float without some additional work. So that will be what happens here. I'm going to show you what's going on with that. But let's go ahead and look at how simple these functions actually are. Let's just go ahead and define, what's the first one should we define? Let's define projected balance. So projected balance and P, R, N, and T are all the values. Now, we want to return an array, right? That's all we want to do. We just want to return an array A that is not using in-place operators. The simplest way to do this, by the way, so I'll do it two ways. It might seem like you need to do this. A is equal to P times 1 plus R divided by N raised to the N times T power. That computes A. That's exactly this formula, right? Now, I want to return A. That will define the function and it will be just fine. If you look, if I do P as a NumPy array, and let's say I do 1,000, 2,000, or 3,000, like I'm deciding how different types of investments. Maybe my interest rates that I'm expecting for these is maybe I invest the $1,000 at 0.1 at 10% interest, and maybe I'm expecting a 5% return on my $2,000 investment, and let's say it's a 7.2% interest rate on my 3,000. Let's say the number of times that these are compounded is equal to, let's say we have annual, let's say we have, let's say monthly, so 12, and then suppose that at 7.2, it's quarterly. Okay, so here's our different rates, and then let's say for times, we're looking at this, let's say that for each one, we can do maybe 5 years, 7 years, or 10 years. Okay, so these are perhaps different arrays. You didn't have to choose these values. I'm just giving you some different ones. The point is that if I look at printing the output of the projected balance with P, R, N, and T, these actual arrays, you can't, if you just call this with nothing, let's just point out what's going to happen. You're going to get a type error because you didn't actually pass in any parameters here, and this is a scope issue. These values have to get passed in here. They don't know. They're not going to work, right? If you're not passing any values, it's expecting to use the P, R, and N, T values here. It doesn't matter if they're defined here. The function inside only knows about the values that are passed to it here. So let's go ahead and do P, R, N, and T. Now, this is returning the array A, that the amount that would be at the end for these various investments. We see that $1,000 at 10% annual return with a compounded just yearly over 5 years will turn into $1,600. A little bit more than that, actually. Whereas 5% interest invested over 7 years and compounded monthly, that produces a $2,836 investment or return. And the $3,000 is a little bit more than doubled at 7.2% interest invested where it's compounded quarterly. In fact, if you compound it annually, this is the rule of 7-2, for 10 years, it should double. That should be just about 6,000. Yeah, it's really close. So that's the 7.2 rule. You can read more about the 7.2 rule and see more details about it. I definitely recommend you check it out and write more about it. At any rate, this seemed to work. Now, what I'm printing is that I returned A. Notice if I return nothing, even though A is computed, right? So I've computed A and I returned A, but I did not assign this output when I ran it to anything. So if I look at, well, what's A? Oh, that was that's a markdown cell where you're supposed to put your output. So let me just go ahead and delete that, create a code cell. There we go. If I look at A, there's a name error. A is not defined. Of course it's not defined. We didn't return anything here. Like, let me just run this again. Let me run this. Now it's a none type that's returned. And even if I returned A, right? So let me return A. But if I just run this code here, This array is returned, but it's an array returned. It's not assigned to a variable. So still A, name error. There's nothing there. If you want an array called A with this balance, you need to say A equals this. It actually needs to assign this array to a variable in this scope. It's just, otherwise this A is just kind of goes away. You just have this array that's returned, but it's not assigned to anything, so it's not available anywhere else. So just showing you this is what you need to do. All right, that's kind of it for projected balance, except I do want to say this can be simplified. Because I'm just computing A and then returning A, it's very simple. You could have it be this simple. I'm going to just take this, put it here. This is the simplest code that you can have here. Notice how simple this is. This code will actually work. It'll still be the same thing. Same A value is returned. I'm just returning the output of this operation. So basically this function's called, this operation is computed, and the output's immediately returned. So I can do that all in this short amount of code. Now, I do suggest that you should comment your code with some explanations as to why it's okay in update balance but not project balance here. So here what we're saying is, I would say, you should have a doc string, and you should put some explanation, not what I'm writing here, because this is something for you to do. Put some explanation as to the formula used and purpose of this function. That's for you to do. And you could say kind of like what the inputs are, what they mean, and what the outputs are. Something useful. You should definitely do that, and have some, code comments like this is, return the compounded, final amount, or the final amount computed using the compound interest formula. Like that's a useful comment, something like that there. You should have something like that. Now you should have a different type of doc string and code comments inside your update balance, and I will be checking for that. Let's go ahead and look at update balance, how that's going to be different. So and I'm just going to go ahead and delete this part for now. You should probably leave like all the things you're doing, but I'm just doing it for space so that it's all on the same screen. If we look at updated balance, let me get rid of that highlighting so it's not distracting. Updated balance, is it updated? Yeah, update balance, not updated. Update balance. It's going to have the same arguments, P, R, N, and T. I'm just going to do the code. I'm not going to do the comments or the doc string. You should still do those though. So here what I want is I want to do an in-place operator. I want to update the principal amount that someone has invested to actually be the amount that they now have. So in this case, right, P, I want P to serve like A. I want this computation to update what the P value is. So it's kind of like I want P to be equal to P times this. How does that work? Well, I explained it in this function where I updated H naught to H. Well, here what I need to do, since P is multiplied to this, before, right, this was subtracted, so I used a minus equals. Well, P times this, I'm going to use a times equal. So this is going to be P times equal, and then I'm going to have the 1 plus R divided by N times T. Because what this is doing is saying P is equal to P times. This is a shorthand. This is an in-place operator. Now, guess what? I can return nothing here. Because P has been updated in place. It's a mutable object. This is where I talked about this in the lecture video. You should definitely watch that, maybe twice, 3 times, going through the material above these activities to really try to understand scope and mutable versus not mutable data types and how this is working. You want to get some familiarity with this because otherwise things will seem a little mysterious. But here's that function. Again, you should have some doc string and code comments to explain what's going on. Now let's look at, and I'm going to get an error first. What happens when I run, so like, let's just look at this. If I do projected balance, here's a good thing to check. P, R, N, and T. And let's print P. Notice P is not changed. And here, I called that function. I'll just do it like this. So we'll assign a variable A there. We'll make A, we'll print A, and we'll print P. So there's A, but there's P. P was not changed by projected balance. Now let's look at update balance, P, R, N, T, and we can print P. Now initially I'm going to get an error. There's that ufunc type error that I was talking about because look at our data type for P. You said, 1,000, 2,000, 3,000. It's of data type int, and you're trying to turn it into a float, because look at the output of this. This is clearly a float, and you're trying to overwrite that inside of something that has a data type int. So the way to take care of this is one of two ways. Is you can either say as type float. When you call P, when you're passing the update balance, you can always just make sure that you're passing it as a type float. Let's see if that works. So that passed a copy actually, so that you notice P is not changing. So that's not, so I should say this is not going to work. I was just saying the function works, but it's not doing what it's supposed to, which is updating P. What you really need to do is when you create this function, or excuse me, this array, is you want it to be as a type float now, so that it's 1000 point, 2000 point, 3000 point. Let's again run this. You'll see that here. Notice this 1000, 2000, 3000. Look how it looks different. 1000 point, 2000 point, 3000 point. Now these are stored as floating points. So now when I call this, notice I'm not returning anything. I'm not assigning any values. Look what happens when I print the P value. That is what this A value was above. It's the same thing because it just updated P in place. Those values just got stored over it. So this is, again, something that you should explain what's going on. You should also verify things involving the rule of 72. These are things for you to do. Make sure you have the code comments, the doc strings. I'm just really showing you the important stuff with the coding in order to get it to work. And you can get things to work even though they're not functioning as they should if you pass something as type. That's creating a copy because you're saying this variable is like it's a version of this other one. Here, it's actually creating this array as a float and then assigning it to P. That's differently than having an array and then casting it in place. It's only what it actually does there is creates a copy. And so then you don't see the overwriting as I showed here in the video. So there's just some subtleties here. So this is probably a part of the video that you might have to rewatch a couple times and play with this. But then in the end, you should make sure you have some cleaned up code here and that it runs and at least has something like that's showing here and also has some doc strings, code comments, and then some explanation in the markdown cell to talk about what's going on here. So, you need to do this create new cells and a markdown cell to more clearly explain results and talk about the rule of 72 and everything. I want you to do a little bit of research on that. So that's it. Thanks for listening, and I'll talk to you in the next video.